Should. Okay, here we go. Section 6.5. So we've talked about. Listen, please. If I drew this thing right here, what would you call that thing right there?
Quadrilateral.
Good. It's a quadrilateral shape. That's what somebody in the other class said. Yeah, it's a shape. Well, yeah, it is a shape. Very good. But more specifically, it would be a quadrilateral, wouldn't it? Because it's a four-sided figure. You couldn't say anything else about it, could you? Now, it kind of looks like something else, but you don't know for sure. What if I did that, and that, and take that, okay? All right, what can I say it is now?
Rectangular.
You can say it's a rectangle, because if you have a quadrilateral with four right angles, it's a rectangle, which also means it's a, what else? It's a parallelogram, right, which means if it's a parallelogram, it means the opposite sides are equal to each other. It means the opposite angles are equal to each other, and obviously they are, because all of them are equal, right? The consecutive interior angles are what? Say it, Hannah. You got it. Supplementary, right? She was mouthing it, so I'll give it to her. Okay, so it's supplementary. She's absolutely right. Which means what? What does it mean to be supplementary? Adds up to be 180. Okay, was there anything else? Oh, what about diagonals? This is kind of review. Not kind of review, it's exactly review. But watch. What about diagonals of a rectangle? What did we learn yesterday about the diagonals?
Diagonals are congruent, and if it's a rectangle, the two diagonals, they will bisect. They'll be equal.
Not just because it's a rectangle, though.
Yeah,
because it's a parallelogram, they bisect each other, right? But because if it's a rectangle, you already said it, they're equal to each other, okay? So they're equal to each other in length because they're diagonals of a rectangle. That's not necessarily true about just a regular parallelogram, okay? It's only true about a rectangle. But it's always true on a parallelogram that they bisect each other. Would you agree? So you got two equal diagonals bisecting each other, which means that and that are equal. Well, I'll tell you what, we'll go like this. Okay, those two are equal. Look, if this diagonal is the same exact length as this diagonal, then if you bisect this one, all four of those lengths have to be equal. Would you agree?
Yes.
All right. And we talked all about that stuff yesterday. Okay, we're gonna do a little different thing here. Let me grab something here. Grab this, and I'll paste it right there. Now, look at this thing. Oh, it's adorable. Okay, watch. I tried my best. I think I got it to work right, even though it might not look like it, but I think it is. That this side is equal to this side, which is equal to this, which is equal to this. All right, so I made it like that. All right, so that they're equal to each other. All right, so they are equal to each other. I think they are. Let me just tell you what. Kind of, oops, I don't want to do that. Let's put it right there. Okay, that's not bad. Rotate, so stick that thing right there. All right, so that's the length of that, right? I'm rotating, so yep. So they are equal. Would you agree? All right. So yeah, it is cool. I'm glad I discovered that. All right, because I really needed that. So anyway, all four sides are equal to each other. Would you agree? Well, we give a name for something, a quadrilateral with all four equal sides, and we call it a rhombus. It's R-H-O-M-B-U-S. Ever hear of that before?
Nope.
Okay. It's called a rhombus. So a rhombus is a quadrilateral with four equal sides. Now, if the four sides are equal to each other, that means these two sides opposite each other are equal, and the other two opposite sides are equal to each other. So if the two opposite sides are equal to each other, congruent to each other, what's true about this whole thing? It's also something we've talked about before. What? It's a parallelogram. That's right. So by knowing that all four sides are equal to each other means it's a parallelogram. Would you agree? All right. Yep.
I thought like squares also had all four sides equal to each other.
Yeah, but they have angles too.
Who said anything about a square?
I said something. Wait.
Did you?
Yeah, because don't they?
We'll talk about a square in a second, okay? So we're just talking about a rhombus right now. So all four sides are equal to each other, which also means what? If both pairs of opposite sides are equal, then it's a parallelogram. So that also means that this angle right here is equal to this one down here, right? Because the opposite angles are equal. Means this one is equal to this one right here. What's true? What else is true about it? These two angles are what? This top one here and this bottom one here are supplementary, right? Because the consecutive interior angles are supplementary. What about the diagonals? That diagonal and that diagonal. Okay. What do we know about the diagonals? They do what?
Bisect.
They bisect each other. So this one and this one would be equal, right? They don't look congruent. Why don't they look congruent, the diagonals? Because they're only congruent when they're diagonals of a rectangle. Is this a rectangle? No, it's not, because I don't have 4 right angles, right? So
would there be
these two are equal to each other. These two are equal to each other, but this and this are not necessarily equal to each other.
Would the diagonals be congruent on a square?
I'm not talking about a square.
Okay,
Why do you keep talking about a square? I haven't even mentioned that yet.
Squares are cool.
Okay. Just hold your horses. We'll get to it. I know you're excited about the square.
Yeah. I hope he has some fruits to do.
All right. So anyway, let's take a look. Let's talk about the diagonals. There's a couple things that are true about the diagonals of a rhombus that are not necessarily true about the diagonals of just other types of parallelograms. Okay? When you have all 4 sides equal to each other, your diagonals, there is a couple things. There's 2 things that are special about those diagonals. One thing is look how they meet each other. Look at this and look at this. Look at that angle right in there. What does it kind of look like? Looks like a right angle. Exactly right. And it is. All right. Now there's a proof for this. We're not going to go through the proof right now. I don't know if we even will. But there is a proof for it to prove that this is a right angle. All right. So there you go. That's one of our theorems. One of our theorems says that the diagonals, let's write it down, that the diagonals of a what? Rhombus are, yeah, we'll say perpendicular. Okay. That kind of sums it all up in one word, doesn't it? All right, so the diagonals of a rhombus are perpendicular, so that means they meet at a right angle. Of course, these other 3 angles right here will be right angles as well, wouldn't they? All right, so the diagonals of a rhombus are perpendicular. Now, I said there was 2 things that are special about the diagonals of a rhombus. The first thing is that they're perpendicular. The second thing is, look at this. Just give you a big hint. Look at this big angle right here, and look at how the diagonal hits that angle.
Angles.
That's right, they're the same angles, which means, what does it do to this big angle right there? What does that diagonal do to that? It bisects it, that's right, okay? So the diagonals, write it again. The diagonals bisect, we'll call it the opposite angles. Okay, the opposite angles. So both diagonals bisect the opposite angles. Everybody see that? All right. So I'll tell you what. Let's get rid of these because I want to do some other stuff. Okay, watch this. This angle right here, this big angle, right, is equal to this big angle down here. And this diagonal is bisecting those equal angles. So that means this angle is equal to this one. Agreed? And that means if this is the same angle that's being bisected, then this one and this one are equal to each other. You get it?
I get it.
All right, and let's talk about this. What about this angle? That's equal to this one, and then guess what up here? That one is equal to that one. Does it make sense?
What would we do with that diagonals?
Wow, they're incredible, aren't they? All right, so there's a lot of stuff that we know. Now, you know what they're going to do on here. I mean, they're going to put in values, right? They're going to put in different angle measurements and different side measurements and stuff like that. And you got to figure out what the other ones are, and you should be able to do that. For instance, if they said this was, I don't know, we'll just make one up. Let's say that's 30 degrees right there. And they ask for this angle right there. Could you find that one? Sure, because this is 90, right? See this right triangle now? That's 30, or this is 30, this is 90. Okay, that would be 60, right? That would be 60 degrees. Does that make sense? Okay, now if that's 60, then this is 60. Then the whole thing is 120, right? You follow me? So there's all kinds of questions that they could ask that you could find, right? So watch, if that's 30, then what's this one?
30.
That's 30. What are these two down here?
30.
30. If these are both 60, then these are both 60, all right? You could just keep going with all these different things. Of course, these are right angles. So look, just by knowing one angle, one of these little angles, you should have been able to find all of these. They could have told you, just a second, they could have told you the whole thing was 60, right? And then you could have still found all the little angles, couldn't you? Right? Because you just take half of 60, right? Because it's bisected. That's 30 and 30, yes.
To find another way out, if you said that only one was 30 and you wanted to find out when that node is pointing to, couldn't you also do 30 minus 180 and find out at the what the
Like
one
this
at the
one?
bottom was, and then just
Well, you could have gone 60.
well, yeah,
30 and 30 is 60, minus 180 is 120, and then split that in half. Yeah, sure you could. You could also do this. Look, remember it's a parallelogram, isn't it? So these two sides right there are parallel to each other. So this 30 and this 30 would equal each other because of what reason? Look, this one and this one would equal each other. Alternate interior angles, right? Okay, you get that? See, that works. 60 and 60, you get it? So it's all coming together, isn't it? All the stuff, you know, not all the stuff, but a whole bunch of the stuff that we've learned all comes together, and we can see how it works nice and pretty with this. All right, now for math's favorite shape. You've been talking about it all day. All right, so it's we're going to talk about a square. All right, and you know, look, you've learned about squares since you were a little kid. But we're going to get a little bit more detailed than you probably would when you were first learning about squares. Now, basically, a square is this. A square is basically a rectangle and a rhombus, kind of at the same time. It's a combination of the two. It's supposed to be R-E-C-T for rectangle, okay? So a square is really a rectangle and a rhombus. So if a square is a rectangle, tell me about all the angles. They got to be 90 degrees, okay? So there you go. And then it's also a rhombus, which means what?
All the sides.
All the sides are equal to each other, okay? Let's go diagonals now. Again, it's nothing new because it's just a combination of two things we've already talked about. It's a combination. So all the stuff that's true about a rectangle is true about a rhombus or a square. All the stuff that's true about a rhombus is true about a square. You got it? So let's just talk this through a little bit. Remember, a square is a rectangle, isn't it? So what's true about the diagonals, the lengths of both diagonals? They're equal to each other. That's right. So look at what we've got. We've got these. I'll put 2. All these are equal, right? Because the whole thing equals the whole thing, but they also, it's a parallelogram, so it's bisected, so all 4 of these are equal to each other. Agreed?
Agreed.
What about the angle up here? It bisects. Now we know it bisects a 90-degree angle, so I don't just have to guess what that is. What would it be? It'd be 45 degrees, so that's 45. I could go around to all of these, couldn't I? And put 45. I'm not going to do that to all of them, but you get the idea. All right. It also, remember, it's a rhombus, so what kind of angle does it make when it bisects right here? It bisects at a right angle. They're perpendicular to each other. All right. So all the stuff that's true about a rectangle fits on the, on the square. All the stuff that's true about a rhombus fits on the square also. Make sense? So a square is kind of like a combination of all of them. So it's a rectangle, it's a rhombus, it's a what? Parallelogram, and it's a quadrilateral, and it's a shape too. That's what somebody in the other class says. I'm like, yeah, it's a little bit too broad, but it is a shape. All right. Is there anything else I need to say about a square?
Are circles hard?
Circles are annoying to find.
I like the circle chapter. It's one of my favorite ones. This and the circle chapter are probably my 2 favorite chapters. But on the trig chapter, I like the trig chapter too. I like that. Yeah. Okay. I think that's pretty much it. Let's do this. Let's do an example, okay?
Of course.
All right. Nothing exciting happened between the break there. So, watch angle FJH. Let's find that. Okay. FJH is 82. So this whole thing, it's 82 degrees. We'll just do that, okay? And find KHJ. Where's KHJ? KHJ is this one right here. Yeah, it's pretty easy. If this whole thing's 82, what's this one right here? It's 41. Because remember, it bisects. We also know that it's perpendicular. So basically, just go what? One math step. What? 90? Let's do 90 minus 41, right? Because it's a right triangle, you're going to go 180 minus 90, which is 90. So you don't even have to do that every time, do you? Just say 90 minus 41 is what, 39? Yep, so 39 degrees right there. Wow, that was way too easy. Let's do another one. They say that this is even easier. They should give you tougher examples. They make it way too easy. Alright, JH equals 5x minus 2. And then it says solve for x. Here we go, you ready? It says GH is x plus 9, so that would be this segment right there. That's x plus 9. JH was this one right here, which is 5x minus 2. And it says solve for x. What do we do with those two? Yeah, they're equal. Because, oh, you know what I forgot? We made a big assumption here. But I was supposed to tell you that this thing is a rhombus. Okay? I just kind of assumed that, but I should have told you that. Okay, this thing is a rhombus. So anyway, so if it's a rhombus, then this side and this side are equal to each other, so you just set them equal and then you solve for x. And let's just do it. It's pretty easy. 4x equals what? 11. So x is 11 over 4, and I think that's 2 3/4, right? Isn't that right? 8, and then 11 minus 8 is 3, yeah. Or 2.75. 3/4 is 0.75. Okay, there you go. That's what x is. Now they could ask you this. They could ask you to find the length of all the sides. That wouldn't be that hard, right? You just take the 2.75, stick it in here, which is what? 11.75 for the whole thing. Okay, there you go. If you wanted to, right now you're not capable of doing this, but some of you guys are taking Algebra 2 now, so you should be able to do this. Oh, you guys have you done trig stuff yet, like sine, cosine, tangent?
Yes.
You haven't done it here, though, have you? Did you do it at home?
Oh, no.
Okay. And so you should be able, look, if you know this side right here and you know these angles, you should be able to find this side and you should be able to find this side, right, just by a simple trig function. But later on, at the end of this year, you'll be able to do it too, so don't feel left out, all right, because we're going to do a chapter on right triangles, and we're going to do some trig, and you'll be able, by knowing this angle, listen to me, by knowing this angle and that this is a right angle, a right triangle, if I know the length of this side, which I do, which is 11.75, I should be able to do some trig and figure out what KH is, and I should be able to figure out what KJ is equal to. All right, won't that be fun? Yep. I bet you're excited about that, aren't you? Okay. All right, enough of that. I think we've covered that enough. Let me find. Oh, I know I got up.
What if Josh died?
Because I was going for this.
Would you care?
Matt, stop. Let's see. Pages. Are you writing this down?
Yeah. Yeah.
Would you miss him, Leo?
Yeah.
All right, there it is. Page 431, 432. We're doing 7 to 12, and then 23 to 30. It's not much at all.
Nope.